This is the formula for gravitational potential energy. And gravitational potential energy is the amount of energy available on an object in its gravitational field.
Gathered by this formula, we can infer that U refers to gravitational potential energy, measured in joules. M refers to mass, measured in kilograms. G refers to the acceleration due to gravity,
9.8 meters per second squared.
a constant amongst all formulas in physics. And H, which refers to height, measured in meters. Now, gathered by delta, which refers to the change in, we can now say that the change in gravitational potential energy equals mass times
9.8 meters per second squared.
times the change in height.
This is the formula for conservation of energy. K1 plus U1 equals K2 plus U2. K1 is the initial kinetic energy, U1 is the initial potential energy, K2 is final kinetic energy, and U2 is final potential energy.
This formula relates to the law of conservation of energy, as all energy cannot be created nor destroyed but is transferred in different forms. For example, when an object is in motion, it has kinetic energy, but no potential energy. But when it is at rest, it has potential energy, not kinetic energy. Therefore, this formula displays that energy cannot be created nor destroyed but is transformed and will always equal throughout an object's motion.
As you can see at the top of the ramp, there is no motion. This is because the energy is being conserved as potential energy rather than kinetic energy and is transformed when moving starts. As he is in motion, his potential energy transforms into kinetic energy, and when coming up the ramp, the energy is yet again transformed into potential energy. Here is a real-life example of the change in total energy. As the pen is wound back, the potential energy builds up. As the potential energy was built up, it is then transformed into kinetic energy through the use of the flinging of the pen. The total energy will thus stay the same due to the law of conservation of energy, which states that the sum of the energy before will always equal the sum of the energy after.